In this lecture of S2 BCom CA Incorporation, we are looking into the subject Business Mathematics, Module 2, that is Matrix. This is Module 2, Matrices. In Module 2, we'll be focusing what is a matrix. So a matrix is represented in such a way that, so let it be a matrix A. So this is matrix A. We'll be representing the matrix in the form of a square bracket. Within the square bracket, we'll represent the elements in rows and columns. Suppose 2, 3, 4 and 5. This is a matrix of row, 2 rows and 2 columns. So it is a 2 by 2 matrix. So 2 by 2 means this is the order of the matrix. So 2 represent M, that is rows, and this 2 represent N, that is columns. So a matrix A is defined in such a way that you can represent the matrix in order of rows and columns, and within the square bracket we define the matrix. Suppose in this case the M is equal to N, that is number of rows is 2 and number of columns is 2. So this can be a square matrix. This is a square matrix. Suppose if M is not equal to N, means it is a rectangular matrix. It's a rectangular matrix. So, for example, if it is order 4 by 3, that is M rows and N columns, that is 4 rows and 3 columns. In this case, M is not equal to N, so it is a rectangular matrix. So we'll represent a 4 by 3 matrix. So 4 by 3 matrix means it should have 4 rows and 3 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is a 4 by 3 matrix. So this is a 4 by 3 matrix. So matrix means the elements will be arranged in the form of rows and columns. So it is 2 by 2 means M rows and N columns. If it is M equal to N, it is a square matrix. If M not equal to N, it will be a rectangle matrix. So this is the introduction part of a matrix. Now let's learn about the different types of matrices. Now let's see what are the different types of matrices. Different types of matrix. So we have row matrix. First one is a row matrix. So row matrix means we'll be representing only the row elements. We don't consider the column elements. So this is an example of a row matrix. We don't consider the column, only the rows. This is a row matrix. And next is a column matrix. Column matrix. So column matrix means we'll be representing our elements in a column. So, and here we don't consider any rows. So it is a column matrix. Now let's see a square matrix. A square matrix. A square matrix means it will be of order, same order, that is rows will be equal to column. So 2, 3, 4 and 5. So it is in order 2 cross 2, that is m and n is equal to same, equal the same. So it is a square matrix. Now let's see what is an identity matrix. Identity matrix. So identity matrix normally represent in the form of I. So I2 means it is identity matrix of order 2. So it will be a 2 by 2 matrix, and the number will be 0. The diagonal elements will be 1 and rest of them are zeros. So this is identity matrix of order 2. And suppose if it is identity matrix of order 3 means the diagonal elements will be 1 and the rest will be zeros. So this is identity matrix of order 3. Now let's see what is a upper triangle matrix. Now let's create another one. Before moving into upper triangle matrix, let's learn about the next one, that is diagonal matrix. In different types we have diagonal matrix. Diagonal matrix. So diagonal matrix means, suppose if I am having an element 1, 0, 0, 2, 3, 4, 4, 5 and 6. So let's look what is a diagonal matrix. So diagonal matrix means a number which passes by like this way. Diagonally is called the diagonal matrix. So another way to recognize a diagonal matrix is A11, A22 and A33 is considered as diagonal matrix. So the row and column will be the same for the diagonal matrix. So if the diagonal matrix, this is the principal diagonal matrix. So if there are number of zeros above the diagonal matrix and this is forming a triangle shape, this is called lower triangle matrix. It is lower triangle matrix. Lower triangle matrix. So this is our triangle which caused by a diagonal matrix. So it is a lower triangle matrix. Suppose if it is in the other way around, that is 1, 2, 3, 4, 6, 5, 0, 0, 0. So we are considering the diagonal elements 1, 4, 6 and the triangle is formed in the upper part. So this is called an upper triangle matrix. Upper triangle matrix. So here the diagonal element is 1, 4 and 6. 1, 4, 6 are the diagonal matrix and the triangle is formed with above the primary diagonal matrix. So it is an upper triangle matrix, and that here the triangle is formed in the below diagonal matrix. So it is a lower triangle matrix. So this is all about diagonal matrix. Now let's see what is a null matrix or a zero matrix. Now zero matrix or a null matrix or a null matrix. A matrix whose elements are zeros are called zero matrix. So this is a zero matrix of order 2 and this is a zero matrix of order 3. Now we have another matrix, that is scalar matrix. Scalar matrix. Suppose my matrix is A, 2, 4, 5, 6. This is a matrix. A is a matrix of elements 2, 4, 5, 6. If I want to find 2 times A, that is 2A. So I want to multiply this element to each element of the matrix. So we'll get the value 2 into 2 will give you 4. 2 into 4 will give you 8. 2 into 5 gives you 10. 2 into 6 gives you 12. So 2A is, you're multiplying A twice, or you can consider it as A plus A. So what will be A plus A? The same matrix is adding twice. 2, 4, 5, 6 plus 2, 4, 5, 6. I think it is not visible in the sense. So 2A is almost similar to A plus A. That is 2 plus 2 is 4, 4 plus 4 is 8, 5 plus 5 is 10, 6 plus 6 is 12. Suppose if I have another question, like you need to find a scalar matrix of a matrix A as elements 1, 2, 3, 4, 5, 6, which is of 2 by 3 matrix. This is a 2 by 3 matrix. You need to find A plus A plus A and 3A. Okay. So A plus A means you are adding this particular matrix thrice. So it will be 1 plus 1 will be 2, 2 plus 2 will be 4, then 3 plus 3 will be 6, and 4 plus 4 will be 8, 5 plus 5 will be 10, and 6 plus 6 is 12. So this is A plus A. Now I am going to add again A plus A plus A. So that will be equals 3, 6, 9, 12, 15, 18. So this is A plus A plus A. Now if I am going to calculate 3A, what will be the answer? It will be multiplying the element 3 to this matrix. So it will be 1 times 3 will be 3, 3 times 2 will be 6, 3 times 3 will be 9 again, 3 times 4 will be 12, and 3 times 5 will be 15, and 3 times 6 will be 18. So this is what a scalar matrix. So in this lecture, we learned about matrix and different types of matrix. So let's write about a matrix. Suppose if I want to create a matrix of order 3 times 4, 3 by 3. I want to create a matrix of order 2 by 3. 2 by 3 means it should have 2 rows and 3 columns. So 1, 2, 3. Another element will be 4, 5, 6. So this is a matrix of order 2 by 3, which consists of 2 rows and 3 columns. Suppose if I want to design a matrix of order 4 times 1, 4 by 1, means 4 rows and 1 column. So it will be 4 rows and 1 column. 4, 2, 3, 4. This is a 4 by 1 matrix. Okay, what about 4 by 2 matrix. 4 by 2 matrix means 4 rows and 2 columns. So it will be 1, 2, 3, 4, 5, 6, 7, 8. This is a 4 by 2 matrix. Okay, so this means your order of a matrix, that is rows and columns, and here all the matrices are of a rectangular array, not the square array, because it's not similar. Okay, now we'll learn about how to compute the matrices in the next class. Hope it is clear for you. If you have any doubt, please clear it during our interactive session.